Okay, so today we got a short problem, or a problem, short problem statement. Longest duplicate substring. Given string is consider all substring contiguous substring. Two or more times the occurrences may overlap. Return any duplicated substring that has the longest possible length. If S does not have a duplicated substring, the answer is this. Longest duplicated substring. I mean, if I could do LCP, yeah, I could just slap a suffix array on this, but I have maybe I can do the suffix array right now, but LCP for sure I cannot do. So I have no clue how that is computed, and I'm definitely not gonna come up with it myself. And probably you can do linear solution, but I'm not sure. I mean, you suffix array is ON if you do the disgusting one, but I mean, I can try to build it. That is crazy. Hell. Okay, let's say I build suffix array in nlog whatever squared, and the bucket algorithm that you sort the suffixes by first 2 to the k characters. So, I mean, I guess I can do that, but then I still need LCP. So, that kind of sucks. Question is, do I really need LCP? Good question. I mean, the length LCP is not gonna be much, so maybe I can brute force it with suffix array, but just maybe. So, because LCP on a non-run, like LCP is not gonna be that much, or maybe it's gonna be, I'm not sure. It could be, what's worst case? You mean you go up the entire thing, and then, I mean, you compare by chars, so yeah, here you can get around. I need to do LCP, bro. I just don't know how to code this. So I guess let's search up on that. Suffix array and LCP code forces edu. Let's check this. So okay, I know, I just don't know how to implement this. Sort cyclic shifts. Okay, that does a count sort. Fair enough. But sort the pairs. Wait, what are the pairs even? That's the permutation and C is the class. So the counts, you make them cumulative, and then what the hell, minus count SI is equal to I. What the hell, bruh? And then class of first element is 0, class is -1, so that's just count sort by first, and then but what are the pairs? So these are the pairs, fair enough, but we already sorted by okay, maybe not. This will only give us an algorithm for constructing a suffix array n log squared n times. I'm not good at strings, so maybe there are some other algorithms. This is pair and this is pair, and we sort by this in the previous iteration, but this is also sorted, so that what? Finding a substring. Comparing two substring of a string. we can compare. So with a lot of memory, I can actually but that's too okay. Fair enough. So I mean, I guess let's do this. So first we grab the size, and then sigma is gonna be 256. Then we first do s plus equals whatever, and then vector int pn cn just like some alphabet, max alphabet n. Why would you do that though? Why would you have max out if n is 10,000? Why would you have cent of 10,000? That doesn't make sense a little bit. No. Why would you have alphabet? That's weird. Why would you have this maximum? Because if alphabet, just pretend alphabet is always 256. Why would you need more than 256? That's straight up just, and you only use cent here. I don't understand, bruh. Let's do just sigma. So first we are sorting by, we are doing this part. So cent of si plus plus cent I minus 1. Awesome. And after we have done that, then we p of minus cent si is equal to I, and then class of p0 is 0 and class is 1 if, oh, that sucks. So if s pi doesn't equal s pi minus 1, then class is, we will have one more class, and then class of pi is class of plus is minus 1. So now we did counting sort here. K 1 to k is more than n, k plus plus. Now we need to make the pairs. So vector pair int. I have no clue how to call that. Oh, you do that pn trick. I mean, this already jumps to the whatever. This already uses the better approach profile. So like count sorting vector int bn cn and then pni is pi minus 1 to k, maybe like that. Okay. Plus n modulo n, and then what happens? Will count sort this also goes from the back, doesn't it? Why this doesn't go from the back? I guess because it doesn't matter. Which we are not satisfied in. I mean, I am kind of satisfied by it, so I don't really care. If I'm being honest. I don't really care. So I don't mind at all. Don't mind if I do. So I don't need pn, I think. I can just do vector pair. I think it was like that. And I should be able to modify this, so code forces edu courses ITMO Pilot Academy. Okay, Cloudflare. I really don't remember this. I really could not do suffix array from memory. Let's check out my submission because I'm not sure who can solve this problem in interview. There is nobody who can solve this in interview, having seen it previously. the same thing twice. Okay. Let's do this again. Vector pair char. I mean, I get. I thought I could do. AI SII sort A begin A end. PI AI and class of P0 is 0 if AI first, AI minus 1 first, no, if class of second, but they don't have classes yet, so if this is the case, then class of AI second, class of AI minus 1 second, else class of AI second, class of AI minus 1 second plus 1. Okay, then we do this. Vector pair of int char okay. AI is equal to class of I and class of I plus 1 to the k percentage n, and here I have I maybe. Okay, then I sort, so sort A begin A end, and I could store the classes, to be honest. I should store the classes. So let's make it a vector classes, and then classes push back C. Okay, I don't have a C. Okay, after we've done that, we say that class of P00, now if the second elements AI first second is equal to AI minus 1 first second, then class of AI second class of AI minus 1 second, else class of AI second class of AI minus 1 second plus 1, no, this plus 1. I think I did it correctly. Classes pushback C. We return this, and I keep all the classes so that I didn't do PI. Shit. PI equals AI second. I think that's correct. So AI second. Oh, the entire pair has to be equal. Okay, well, it's not that hard, I guess. But you have to go from this to n log n, and then going to on is crazy. That's an interesting trick. I didn't think about that. So first should be a. So that's 5, 0, 1, 2. I mean, there should be 6 somewhere in there. So 6, 5, 3, 1, 0, 4, 2. Looks like it works. So if I compare equivalence classes, so I keep the equivalence classes. For int k classes size -1 k minus minus. Okay, so we are here now. I got the biggest class. If they equal by the biggest class, application comparing to substrings. So what we want to do is, so I want to run this for all the pairs. That's crazy, dude. I mean, I can run it from here, but that's a useless iteration. And what I want to do here is, well, int unsave this. Int k classes size, int k minus 1, k 0, and if class k of I minus 1 in ci I minus 1 cj I, and now if ci percentage n class of ci equals class of k of cj 1 to k, and ci plus 1 to k percentage n, and cj plus 1 to k percentage n, and maybe this should be it's like that. And now string ans. If ans so int ans l is this, and then string ans is this. No, we ans position is -1. So what we want to do is this. If ans over ans length, ans position is I. Okay. And now if ans position -1, we return this. Otherwise we return S. Actually you don't want I, but maybe you want substr from ans p ans l maybe. What are you yapping about? Oh. Anna. So is substr I -1, no. I ans. Will give nothing for all of them. That's awesome. Awesome. Awesome, awesome. Yeah, I do it wrong. That's not. You want to tell me there is never an equivalence of any classes? So if, what are the first two substrings? Anna and Anna. If I is free, so K classes K Ci classes K Cj Ci Cj printing the wrong K. Did I even implement this correctly? Of course I didn't. Hell nah, bro. Hell nah. What the hell? AI is AI second, and then if AI first, this, then C of, I mean, I guess it's correct. It's correct. Whatever, who cares? Class of this +1. So CPI minus 1, CPI minus 1 plus 1. CI, this, we sort, then we have AI second, C0. If AI first, then the same thing. So I mean, the algorithm is correct. What I don't understand is the classes. That is weird, bro. That is weird. So let's do for each iteration. Let's output the classes for auto x in C. I wanna see the classes, bro. There should be classes. Should be pi minus 1 and this should be pi. Maybe now it will work. Okay, now it works. Great. Okay. So that took a while, but wrong answer on. Okay, that's funny. How, bruh? How is it? That's made funny. Oh my god, bro. PI and then arms. Zero, 1, 2. So you start there. Like this. Okay. So it was just a logic error. That's weird. You get some sort of overflow. Okay, well, minimum of answer L and s minus ans position, maybe. Still something wrong. Debug. Okay, so we didn't even get here. It's nice. Okay, we got here. So something went wrong in this phase. Should be the same thing completely. So after we make the pairs, it should be absolutely the same thing. Which is weird that it doesn't work. Oh, I didn't. Then something's wrong with it. Pair int. Oh, oh my god. Okay. Ooh, I beat most of the people. Ha. Suffix array. If we build the suffix array of the string and store the equivalence classes of substring of length of substrings with length of power of 2, we can compare we build the suffix array of the string and store the equivalence. If we build the suffix array of the string, we just have to find the longest common prefix among adjacent suffixes approach. We can build the suffix array with an arbitrary O n log n squared approach. Arbitrary O n or faster approach. We also store the equivalence. We first build the suffix arrays with the O n log n2 approach. O n log n would also work. Maybe even the we also store the equivalence classes in each iteration, including the 0th one, to compare adjacent suffixes. We first compare them by their first 2 to k characters which is stored these classes are already computed and stored in classes k, I, and pi minus 1 in classes k. If they are the same, they share a prefix of length of at least k. We update the pointers to which positions to the pointers to which suffixes we are looking at from I minus 1 and pi to pi minus 1 I minus 1 plus 1 to k percentage n and respectively. Then we do this check for if not, we do not, if not, their longest common prefix is of length like the k, so we do not add anything. We do this for all values of k, decreasing to 0. After this process, we will have the length of their longest common prefix. So we update the current answer by 2 to k and okay. Time complexity is, I don't know, n log squared n when not using radix sort, to use radix sort to sort the buckets if the longest common adjacent prefix takes O of log n time for each pair of adjacent suffixes of which there are on. Using radix sort, we get down the final time complexity is O of n log n. O of n log n, since we store all equivalence classes for each of the O log n iterations. Okay, I mean, this approach I think I can call, but whatever. Okay, interesting problem. Maybe I will remember the suffix array, at least this construction for once. Goodbye.